Okay. Um, Now we will do some problems based on the limit. Okay. For a finite limit case, we do some problems, right? For a finite limit case, suppose x tends to 1, like as x tends to 1, x tends to 2. We already do some problems, right? In the we already do some problems based on the this infinite limit. That means n length infinity. Now we are doing the problems based on the finite limit case. I mean, x tends to 1, like the problems, right? You want to show that, right? It is your question, right? It is exercise number 1, right? Prove the following limits, right? Prove the following limits. Okay, prove the following limits. First question, right? Prove the following limits. That means you want to use the epsilon delta definitions. You want to prove that the limit is exit. Okay, that means limit of x length to 1, x squared plus 7x. Obviously, this value should be 8 now, because you put here x is 1, you get 8. Okay, now we use the epsilon delta definition. You want to prove this condition, right? Before that, you want to understand, suppose limit of f of x, x tends to a equal L, this limit exit, if and only if you will write epsilon greater than 0, the direct is delta greater than 0, such that, is it okay? Such that right, if and only if for all epsilon greater than 0, the direct is delta greater than 0, such that modulus of f of x minus L less than epsilon for all x satisfying, okay, s satisfying 0 less than x minus a less than delta, right? First you want to understand this satisfying 0 minus x minus a less than delta, right? Now today we are doing the problems based on this condition, right? Very important, this limit condition. Suppose they will give this limit values, everything, then you want to prove that using the epsilon delta, you want to show that f of x minus L less than epsilon. It is your claim. You can assume that for all x satisfying this condition, you can assume that this condition is satisfying. Then you want to prove that this f of x minus L less than epsilon, right? That is your question, right? Today we are doing some problems under this definition, okay? Under this definitions. First question, limit of x tends to 1, s squared plus 7x equal to 8. For that, you will write like this: let epsilon greater than 0 be arbitrary. You can choose any numbers, epsilon greater than 0, arbitrary number, right? Your claim is, for this question, what is your claim? You can roughly you can think about this one. For this claim, your f of x this one, your L is 8, a is 1. Therefore, you can roughly think about this one. S tends to 1, f of x s squared plus 7x. You want so that 8, if and only if for all epsilon greater than 0, they are like this delta greater than 0, such that your f of x s squared plus 7x minus 8 less than epsilon for all x satisfying, right? 0 less than x minus a is your 1 less than delta, right? These things you want to do it, right? You want to assume that for all epsilon greater than 0 and delta greater than 0, and for all x satisfying this condition, you want to prove that s squared plus 7x minus 8 less than epsilon, right? You want to prove that s squared 7, right? S squared 7x minus 8, 7x minus 8 less than epsilon, right? That is your claim now. This one. Okay, now we will start from here for all epsilon greater than 0. Okay, right. Now you consider, consider this modulus of s squared plus 7x. You want to simplify first this part. How can you simplify? You can factorize. You will get x minus, x plus 8, x minus 1. Choose, first we choose, right? First, better way, right? If you here, right, you assume that if, okay, this condition, okay, you put here star, okay, you put here star. First, you assume that if, right, if here 0 less than x minus 1, you put any values here because delta should be greater than 0, right? You can put any positive value for delta, right? And now I will put, what is the value I will put? Now I put the values half. We can put, because delta greater than 0, no, we can put half here. Then you can find the x value, right? We can release the modulus, then you will get the values of x. What is the value of x? You release the modulus, we will get minus half x minus 1 plus half. You simplify this one, we will get here plus 1 minus half x 3 by 2. Okay, half x 3 by 2. So now what is the value of x plus 8? If you get x plus 8 values, we will write less than, put here for x value, you will put, suppose you put x value 3 by 2 means, right? We put here not equal, it's less than sign, 3 by 2 plus 8. What is the value? 19 by 2. Okay, 19 by 2. Now you will consider here again this star, right? Star implies, right? Star implies s squared plus 7x minus 8. Okay, s squared 7x minus 8. Okay, right. This one already factorized x plus 8, x minus 1. Now your x plus 8 less than 19 by 2 into, you already know that here modulus you will write modulus of x plus 8 into modulus of x minus 1. But modulus of x minus 1, we already have modulus of x minus 1, we will put this value, delta, right? Here you put delta. But now your claim is you want to show that this one equal to epsilon. That is your claim, right? Now your claim is this 19 delta over 2 equal to epsilon. Okay. For that purpose, right? For that purpose, we choose, right? We choose the element here. Choose your delta, right? Minimum of, there are two values because you already take one value half, right? Half. Now another value here, right? Choose delta, right? You want to prove that this one equal to epsilon, right? 19 delta by 2 equal epsilon. Therefore, what is the delta value here? 2 epsilon over 19. You choose delta value as a 2 epsilon over 19, right? Right? 2 epsilon over 19, right? We will get here less than epsilon, right? Because here is an equal 19 by 2, right? 19 by 2 into, for delta, here you take the minimum of this half, 2 epsilon over 19, right? 2 epsilon over 19, okay? 2 epsilon over 19. Suppose you take here 2 over 19 epsilon, you will get here epsilon. That is your claim, right? That is your claim, epsilon, okay? Right. Now we prove that s square plus 7x minus 8 less than epsilon, right? That is, right? That is, there exists delta greater than 0 such that this s square plus 7x minus 8 less than epsilon for all is x satisfying, okay, for all x satisfying 0 less than x minus 1 less than delta. Okay, this condition okay. Since you take arbitrary, right? Epsilon greater than 0 is an arbitrary number, right? Therefore, since epsilon greater than 0 be arbitrary, for an arbitrary number, this result is true, right? For arbitrary number, this result is true. Therefore, for all epsilon values, this result is true. Okay, that means for all epsilon greater than 0, there exists delta greater than 0 such that we will have s squared plus minus 8. We prove this condition, right? We prove this condition for all x satisfying 0 less than x minus 1 less than delta. Therefore, right, it is if and only if that is limit of x tends to 1, I will inform it is if and only if this one, no, s tends to 1, s squared plus 7x equal 8. Okay, s squared 7x equal 8. Okay, it is the question, right? Now you understand what is the step we want to consider, right? First, you want to take the arbitrary element epsilon greater than 0. Now, hereafter you want to consider this s squared plus 7x minus 8. Your claim is you want to show that s squared plus 7x minus 8 less than epsilon. For that one, we will do some things here. If you want to take for a delta values half, then you will get x range. Suppose you want to take the x plus 8 modulus value should be less than 3 by 2 because s less than 3 by 2 means modulus of x also less than 3 by 2 plus 8. This value 19 by 2. Then you can get the value for this one less than 19 delta or 2. But you want to get here 19 delta by 2 equal epsilon. Therefore, what is the value you want to choose for a delta, right? What is the value you want to choose for delta here, right? That delta value should be 2 epsilon by 19. Then you will get epsilon value. Therefore, since we take epsilon greater than 0 be arbitrary, therefore this result is true for all n. Sorry, this result is true for all values of x, right? It is the proof, right, for the finite limit part, right? Next question. Next question. Similarly, we can do the next question like this method. We can use it again. Right. Next question. Limit of x tends to 0, 2x squared plus 7 over x plus 1 equal again 7. Now you put here x is 0, so here 0, 0, 0, 7 by 1, 7. Same idea, now we'll do let epsilon greater than 0 be arbitrary. Okay, now you consider, right now your question is this one. You can roughly, your question is this one. S squared, 2s squared plus 7 over x plus 1, s length to 0. Here 2s squared plus 7 over x plus 1, what is the value here? 7. For all x minus 0, right? Now you want to prove this one now, okay? Now you want to prove this one. 2s squared plus 7 over x plus 1 minus 7 less than epsilon, right? That's the thing you want to prove that. Here L is, what is the value L? 7. Consider 2s squared plus 7 x plus 1 minus 7. Okay, now this part you can here 2x squared plus 7, here ECD is plus 7, 7x minus 7, therefore x one, you can easily simplify this one, okay? Right. Now you have 2x squared, you can take x is 2x minus 7, x plus 1 modulus. Okay, x plus 1 modulus. Okay. You want to show that this one less than epsilon, right? For this one, we can use this condition. 0 less than x minus 0, therefore modulus of x less than delta. We can use any values of delta. Let me check now. Okay, now we can do some arrangement. You add 2, then subtract 9, then x plus 1. Is it okay? Then you have x 2 minus 9 over x plus 1. It is another way, right? But this we can do this way, right? There are some ways, right? It is one of the way. Okay, now this one should be 2 modulus of, is it okay? 2 modulus of x less than 2 modulus of x. We have here x minus 0 less than delta. That means modulus of x less than delta. Modulus of x less than delta. Therefore, it is 2 delta. Here you don't need to choose the delta values, right? Like a previous example, we choose the values like delta as a half. No, here it's not need for us here because we have 2 delta. Our claim is you want to show that this one equal epsilon, right? It's an equal epsilon. Therefore, we want to choose. That's okay. Choose what is the value delta. For what is the value delta, we want to choose for delta to get the epsilon. That means you want to get here epsilon. Okay, what is the value you want to choose the delta? Epsilon by 2. Delta equal epsilon by 2. Okay, you choose these values, then you will get their rectus delta greater than 0 such that your 2 x squared plus 7 over x plus 1 minus 7, okay, minus 7 less than here this one less than 2 delta, but 2 into delta you are epsilon by 2, therefore you get epsilon for all x satisfying 0 less than modulus of x less than delta, right, less than delta. Therefore, since epsilon greater than 0 be arbitrary, okay, therefore this result is true for all n, sorry, this result is true for all epsilon values, right? For all epsilon, this result is true. That means for all epsilon greater than 0, their act is delta greater than 0 such that 2x squared plus 7 x plus 1 minus 7 less than epsilon for all, right, x satisfying 0 less than x minus 0 less than delta, okay, less than delta. This one if and only if this one, that means that is limit of 2x squared plus 7 over x plus 1 x tends to 0 equal 7, okay, 0 equal 7, okay. Next question is limit of x tends to 2 3x squared minus x minus 10 over x squared minus 4. This one 11 over 4. Okay, now your question is s length to 3x squared minus x minus 10 over x squared minus 4, 11 over 4. It is your question now, right? It is your question now. Now you prove this part. Let epsilon greater than 0 be arbitrary. Consider this part. 3x squared minus x minus 10 over x squared minus 4 minus 11 over 4. Now, the GCD is 4 into s squared minus 4. Similar this one, 12 s squared 4x minus 40, 11 s squared 44. Now, 12, 11 means x squared minus 4x plus 4. 4 times s squared minus 2. Now, you factorize this one, we will get here x minus 2, one of the x minus 2 cancel here for x plus 2. Right? We already have x minus 2 less than delta. Okay. For that, if, right, we put here star. Now, I do these problems like first problems, right? Well, that be also okay, right? Otherwise, if you add here 2, then minus 4, that is another way, right? Understand? You can do this problem like a second question, you can do, because you can add here 2 and subtract therefore minus 4, then you can do something problem. Otherwise, you can do this problem like a first problems. But think if 0 less than x minus 2 less than, you can choose one of the number. I choose half. No problem. You can use here 1 or 1 by 4. Everything okay, right? But should be positive. That's important, right? For any values is okay here because delta greater than 0. Therefore, any positive value is okay, but should be here positive value, right? Right. We can choose here half, no problem. You can choose 1 by 4, 1 by 8. Everything you can use it, right? Now, if you get this part, you have minus half x minus 2 plus half. Then you will have 2 minus half means 3 by 2 less than x 5 by 2, right? 3 by 2x 5 by 2. Okay, now same idea, right? Like a first question, choose your delta minimum of, what is the value here? Half. No, we choose half. You already know that, right? Here, right? You already know that, right? Suppose in the star, you already know that. From this step, you have, suppose you already have this x minus 2 is less than delta. Delta over 4 times. What is the modulus of x plus 2? Right? From this one, modulus of x plus 2. You can add here 2, here 2, right? Then you will get the modulus of x plus 2. Therefore, this modulus of x plus 2 must be, right? What is the modulus of x plus 2? Must be, right? Modulus of x plus 2 means, understand, modulus of x plus 2 means must be, I'm saying here, you can add this here 2, then 2, you will have, therefore, 5 by 2 less than modulus of x plus 2 less than 5 by 2, okay? Okay, because all are positive. X plus 2, right? X plus 2, here we add 2 here, 9 by 2. Suppose this formula is a, this x minus 2 for x plus 1 less than this values means you want to put here this value should be the smallest value, no? Here you want to put the smallest value. Therefore, possible for x plus 2 is this one, 5 by 2. Okay. Five by 2. Then you will have, uh, 2, no? Therefore, you will have delta over 10. But you want to prove that delta over 10 equal epsilon, okay? Delta over 10 equal epsilon. Therefore, delta over 10 equal epsilon means you want to choose your delta value is equal to 10 epsilon. Then 10 epsilon, okay? 10 epsilon. Therefore, right, 10 epsilon. Therefore, you will put here 10 epsilon means delta over 10 into 10 epsilon, sorry, your delta, sorry. Here delta is values 10 epsilon, okay. 10 epsilon over 10, 10's cancel, you will get epsilon, okay, right. That is, there exists delta greater than 0, we will prove. We prove this condition delta greater than 0 such that 3s squared minus x minus 10 over s squared minus 4 minus 11 by 4, right, less than epsilon for all x satisfying, right, x satisfying 0 less than x minus 2 less than, right, x minus 2 less than delta, okay. Since epsilon greater than 0 be arbitrary, since epsilon greater than 0 be arbitrary, therefore the result is true for all epsilon greater than 0. That means for all epsilon greater than 0, the Rx is delta greater than 0 such that 3s squared minus x minus 10 over s squared minus 4 minus 11 by 4 less than epsilon for all x satisfying 0 less than x minus 2 less than delta. Therefore, we prove this condition, therefore, is given only if this condition is satisfying. That means this condition is true. That means limit exit, limit of 3x squared minus x minus 10 over s squared minus 4 s length to 2 is limit equal 11 over 4. Therefore, this limit equal to 11 over 4. It's okay? Right? This limit equal to 11 over 4, right? Now, next question. we do. Now we will do the next question. Right. Now we will do the next question. The next question is limit of x tends to 1 2x to the power 4 minus 6x squared, so s cube x squared plus 3 over x minus 1 equal minus 8. Okay. It is 4 no. Right. Now we will do this problem. Okay. Here you can roughly think about this question, right? Two x power 4 6x cube s squared plus 3 over x minus 1 equal minus 8. Right. Here 2x power 4 minus 6x cube s squared plus 3 over x minus 1 plus 8. Minus minus 1 plus 8 less than epsilon, right? That is your claim, right? Okay, now, right now, let epsilon greater than 0 be arbitrary. Okay, be arbitrary. Now you consider this one. 2x power 4 minus 6s cube s squared plus 3 over x minus 1 plus 8. This one implies you can factorize is a polynomial degree 4, no? It's polynomial degree 4. Your GCD first, you can simplify this one. Your GCD x minus 1, you will get 2x4 minus 6x cube s squared plus 3, 8x minus 8 over x minus 1. Now again you can simplify it. 2x4, right? 2x4 minus 6x cube, right? 6x cube s squared plus 8x s squared plus 8x minus 5 x minus 1. Now you can factorize this one. You already studied how can you factorize x minus 1 times 2x cube x to the power 4 minus 4x squared minus 3x plus 5 minus 1 plus 5 minus 5 x minus 1. Now you can cancel the term x minus 1. Then you can again factorize x minus 1 times this one 2x squared minus 2x minus 5 minus 1 plus 1. Again factorize. Now okay. Now choose if 0 less than x minus 1 less than, you can choose any values for delta, right? Delta greater than 0, you can choose any values for delta. I choose here 1, right? I already mentioned. Then what is the x value? Then 0 less than x less than 2. Simplify this one, you will get this 0 less than s less than 2. Now for this part, right? For this part, can I write this part? Modulus of, okay, modulus of 2s squared 2x minus 5. This one less than 2 times 2 squared, you add 2, here 5. Here subtract minus 2 minus 5. Suppose you add plus that form, this this term should be the liar term, right? From this one. Therefore, this term is a liar one. Okay, we can add, because here put less than sign, no? Right. This one equal, 2 into 2 is squared 4. 4, 2, 8. 4, 5, 17. Therefore, right, this one less than 17x minus 1. We already have this one 17 delta, no? X minus 1 less than delta, no? This one less than 17 delta. X minus 1, no? Here 1. X minus 1 less than delta. Therefore, x minus 1 less than delta. Therefore, 17 delta. Now you understand what is the value you want to choose for the delta. Delta equal minimum of, we only use one value, delta, here 1. 1. Now you want to get here epsilon. That means 17 delta equal epsilon. Therefore, delta equal epsilon over 17. Choose the value. Epsilon over 17. Or positive. Okay. Right. Therefore, suppose you choose this delta equal epsilon over 17. You have here 17 into epsilon over 17. We have here equal epsilon. Okay, equal epsilon. Therefore, right, therefore, there exists delta greater than 0 such that this one, this formula, this one less than epsilon, this one less than epsilon. Plus 8 less than epsilon for all x satisfying 0 less than x minus 1 less than delta. Since epsilon greater than 0 be arbitrary. Therefore, for all values of epsilon, the result is true. Means for all epsilon greater than 0, there exists delta greater than 0 such that 2x4 6x cube is squared plus 3 over x minus 1 plus 8 less than epsilon for all x satisfying condition 0 less than x minus 1 less than delta. This one means the limit exit, right? This one means here now we prove these conditions if and only if this condition is true. Therefore, this one is true. That means that, okay, this one is true, right? Means limit of, that is limit of x tends to 1, 2x to the power 4, 6x cube, s squared plus 3 over x minus 1 equal minus 8. Right? It's minus 8. Okay. These are the some problems based on the limit, right? you know the limit value, you want to use the epsilon delta, then you want to prove the limit condition, right? Right. Okay. Okay. Okay.